I collected this data set from the Refin website, and right now it's displaying the first 10 properties from the data set. And you can see that it ranges from address, city, and state, and then the variables which I use in my regression, the price, bed, bath, square feet, age, east, north, and south. West also included in the dataset, but is not included in my regression model because since there are four of these dummy variables, they are all correlated with each other. So by removing it or having West variable be the base, it avoids perfect multicollinearity. And I mentioned previously that I will be using a log linear regression, which means that the beds, bath, square feet, age, east, north, and south, the x variables, will, will have no transformation whatsoever except for the price. The price will be logged. In order to get the log linear regression results, I need to find the estimate, the standard errors, the t-values, and the p-values. And you can see that for each of the four values on the right side, there is a function, or an equation rather, that will allow me to perform certain matrix operations in order to get these values. Once I find these values, I then have a Python output it as very similar to like a table found when you do a regression in R, where you have the variables, the estimate, the standard error, the t-value, and the p-value in that order. After running the Python program, all of the estimates are statistically significant, with the p-values being less than alpha, which in this case is 0.1%. Now, since I ran a long linear regression, this means that the estimates are interpreted a little bit differently. Once Python outputs the regression results, they are in decimal form, but they are actually referring to a percentage change. So for example, bathrooms, the decimal form is 0.08107, which means that for every additional unit of bathroom that is added to the property means that it will increase the property's value by about 8.107%. Now, the estimate coefficient for bedrooms is negative. One of the reasons for this is because if you hold square feet constant and you add an additional bedroom to the property, there is less living space, which might make the property less attractable. To fix this, I could have added a bedroom squared interaction variable, and that would make the bedrooms coefficient positive and the bedrooms squared coefficient negative. And the reason for this is because if you add an additional bedroom to the property, it will increase the property's value, but at a decreasing rate because of that decrease in the living space. Same argument could be said about bathrooms as well. Now, if I were to do that in order to get a specific percentage number, I would have to take the partial derivative of the log price with respect to bedrooms, and that's a little bit of a hassle to do. Now, my data set or my results is useful for property developers and property investors. If they want to look at the market conditions, if they want to see if what the percent change in the sales price would be if they added an additional bathroom or an additional bedroom or additional bathroom. And my results, this is important, I would say, my results are restricted to the Phoenix metro area because if I run the same log linear regression to the Las Vegas housing market or Los Angeles housing market, or the Chicago housing market, they are going to produce different results because the markets over there are going to value things differently, different amenities, different circumstances, different factors that influence these sales price of residential properties.